Okay, we were at a radius of 1 and going up absolutely nothing. So we're just there. Okay, next point I have in front of me is 0 pi 6. Okay, radius of 0 up pi 6. So we're at the origin. What's the next one? So in a decimal, that's negative 7.3.
I thought this was 1 plus root 3.
Oh, I can scooch this over. So this is my radius right now, right? Is that the next point? Yes? Okay, 1 minus square root of 3. What is that as a decimal? Okay, so about right there, and we're going how far down? Pi thirds. So pi thirds, right there. So those are my 3 points right now. Next point was negative 1, and then pi halves. So I'm right there. Okay, next one is at 3. So 1, 2, 3. And what was my radians? 3 pi over 2. So over, down, I'm right here. Okay, next one, 1 plus square root of 3. So I'm at 2.73. 2.73. Yep, and my radians was 5 pi thirds. So up, down, and about right there. Should have been that point right there. Okay, next one was 2. 1, 2, and what's my radians? Anybody? What was it on my sheet? Oh, 11 pi 6? Okay, so 11 pi 6. So right there. And my last one was 1 and 2 pi. So 1 and 2 pi. So right back there. Okay, so I started with quadrant 1 and we went to quadrant 2. So I'm just going to start here. And I'm going to go down and around. So this point was the start of quadrant 4 points, right? It should be. Start of quadrant 4. So quadrant 1, if I'm going in a circle, we kind of end in quadrant 4. But quadrant 4 and quadrant 1 are right next to each other. So we're just going to go quadrant 4 points to quadrant 1 points. So we're going to go down, around, keep going. This was my next point. And then it kind of loops around because we're talking about curves. And we're just connecting the points so it looks like that right now. And we had symmetry where in this problem? Pi halves. So we're talking about this line right now. Pi halves. So we're going to flip our entire graph over this entire axis. So if I'm at like this point right here, I'm going to flip it over and I'm right there. This point, I'm going to flip it over, I'm right there. This point, I'm right here. This point is right here. And we're going to connect it the same way again. Starting down, going up, looping it around, going through my origin, and going back there. Anyone have any questions about graphing these points? Or connecting the curve? No? Okay, you want to try one on your own? Yep. Okay, let's do a sine one this time. We'll do this up on the boards. This next one would be y equals 3 plus 2 sine of theta. Why don't we just start with making the table and finding our points? And if we need help graphing, that's totally fine. Yes. So since this is a sine function, where do we have symmetry?
Yeah.
Yeah. Was the last one a sine function?
Yeah.
Oh. You want a cosine function? Sure. Okay. We'll do cosine for the next one because it looks prettier for the next one. Let's keep this for right now. So we have symmetry over y equal pi halves. Yeah. Do you want to check symmetry over the pole as well? Okay.
I thought that was only over the pole if there was something in front of it theta.
Exactly. So we don't have to check it, but I just want to see if you guys want to check it to prove that it's wrong. Okay. Then let's just find the points in our table. Let's do groups. Yeah? Groups up on the boards just to find our points. And if we need help graphing, that's really fine. Okay. Random generator, you just want me to do you have cards? You guys have cards. Let's just do
We're missing one, so I don't know how to get
Yeah.
it out.
like from here or just you don't have
One person in class. Two people, but
So you're all gonna need threes and twos and these decks. And fours and aces. So find person. This is an ace. You're an ace. You are a four. So find the other.
Why's there no threes?
Four and three.
Here.
Okay.
There's an ace. Beagles?
Ace will be group one. Group one is over there. Two is in the back, and then there's three and four.
Yeah. Where's three at?
Three
Where
is over there. I was like, where's four? Record. Okay. I need more room. Okay, we are moving on to a rose curve. Rose curve. And if you see in your notebook, they also have symmetry, but they have different n values. So we have y equals a cosine of n theta, or we can have it as sine. It's a sine of n theta. Now, it matters if n is positive or negative. That's like the biggest thing. If n is odd, we have n number of petals as our roses. However, if n is even, we're going to double the amount of petals. We have 2n number of petals. Yep.
the equations above are R, right? R equals instead of Y equals.
Yep.
Okay.
So before we switch polar to rectangular, this is giving us nice graphs of these. I want to find it. Where is it? Okay. All these rose curves have symmetry through the pole. We might also have other symmetry as well, so we do have to check all of them. So let's do an example.
I thought the pole wanted to add both. Or no?
So if you have both, then you also have the pole. But you can also have neither and have the pole. Yeah. Just if you have both, then you don't have to check the pole because it's just applied. Yep. Okay, let's do an example. let's do r equals 3 cosine now of 2 theta. How many petals is this rose going to have? 4 petals, yep. So this n, so our 2 is our n, 2 is even, so we're going to double the amount of petals we have. So 2 times 2 gives us 4. So we have 4 petals. Okay, let's check our symmetry. R of theta equals R of negative theta. So that means if we have R equals 3 cosine of negative 2 theta, is that the same as our original function? So cosine is an even function. So that implies whatever the argument, if it's negative, inside, it's equal to the positive argument. Yep, it's the same. So same as R equals 3 cosine of 2 theta. So, okay. Fun fact, cosine is an even function, which implies that this statement is true. Cosine is even function. So I have a negative argument. The negative kind of disappears, and it's just a positive. It's the same thing. The negative arguments equal to the positive arguments. Yes, only for cosine. For sine, it's an odd function. Yeah. Do you want to write what sine is? So we have it? Yeah. Okay, it's an odd function. So sine with a negative argument is the same as negative sine of x. So the negative would come out because it's an odd function. Sine is a odd function. So that would be true for sine. Okay, we checked the first one. What does the first one tell us? Where do we have symmetry now? Polar axis? Do we agree? Yes. Polar axis symmetry, which is true for cosine. Now we gotta check another one. R of theta, let me pick a lighter color, equals R of theta minus pi minus theta. So I'm replacing theta with pi minus theta. So if R equals 3 cosine of 2 times pi minus theta. Karina, what should I do with that 2 inside here? Yeah, distribute it out. So I get 3 cosine of 2 pi minus theta. What does 2 pi represent in a circle? Yeah, you're right. Thank you. What's up? So that was the symmetry we talked about yesterday. So we have to check each one. Yes. So this was the first one. This was the second one. So we're seeing if it has symmetry over pi halves right now. If it's true, if this is equal to the original statement, then we have symmetry. We're checking. Yeah. What does 2 pi represent in a circle? I start at 0 and I go 2 pi. A full circle. And I'm at the same exact point, right? So the 2 pi does not change what theta becomes at all. So it does not change it. So I'm left with 2 equals 3 cosine of negative 2 theta. And that's the same thing we started with the top one. What happens to the negative? Yep, it's just positive because it's equal to the positive cosine arguments. So 2 pi is just going around the circle again. So it doesn't change theta at all. So it just disappears. It doesn't, yeah. And we're just left with negative 2 theta, which is same as 2 theta. Because it's an even function. Yep. So a negative argument is the same as the positive arguments. Cool. So we have symmetry.
I don't see
Great.
how that proves we have symmetry. Like, I don't understand what that has to do with the
Say it again.
Like, the answer we got, I don't see how that relates to the thing we're trying to find symmetry with.
So we're trying to see if this equation, if we plug in this, if we get our original, if our top one. So yesterday we showed, I'm just going to scooch over for a second. I'll go back if you want to write notes.
Okay.
This was our symmetry. So when we do pi minus theta, that means it's going to be the same exact thing, but on the other side. So if we flip it over pi halves, it's going to be the same thing on the other side. So we're just checking if that would be true, which you've shown that would be true. Yeah. Okay. And if I have symmetry for both, what does that tell us? We also have symmetry at the pole, which we don't need to check anymore. Okay, so we also have symmetry at the pole. So if we have symmetry everywhere, what quadrant do we need to plot points in? Yep, just one. So just need points from quadrant 1.
That's symmetry number 2.
Number 2 is symmetry over r equals pi halves, which we have. So back to our symmetry, I'm going to scooch back over. Sorry guys, scooching back over. If I have a symmetry over the y-axis, if I do 1 and 4, and I flip it over, then I have all 4 quadrants, right? Yeah. And if I have over at x, then I just have to do 1 and 2, and I can flip it over, and I have 3 and 4. Yeah, so if I have symmetry everywhere, that means I can flip it 1. If I'm in quadrant 1. Yeah, and if I'm in quadrant 1, I can flip it over y and get all those. Then I can flip it over x and get all those. And I can flip it over the pole and get all those. So you only need to find these points, and I can flex it over everything and get all the points. So we don't have to do the entire table of all the values. We only have to find one, because we can flip it over here, flip it over here, and flip it over the pole. Yeah. Casey, do you have any questions? No? You got it? Yeah? Do you have a question? No? Okay. So we have symmetry over the x and y axis. Yeah.
Question. When you're solving for symmetry, I don't understand, like, I should have asked this.
It's okay.
Like, the first line of finding symmetry, did you plug stuff in, or where did that come from?
Tell me where. Here?
Yeah, and then on the next one.
This one?
Yeah.
Okay. I'm just changing theta to minus theta. So I'm just going to plug in, instead of theta, we're making it a minus theta. So whenever we see theta, we're going to plug this in to our equation. So whenever I see theta in my equations, I see it here. So I'm going to plug in that into it.
Okay.
Just changing it.
Okay.
Yeah. Okay. Are we ready for our points? Okay. Let's do 3 columns. We have r, we have theta. What's our equation? 3 cosine of 2 theta. Krina, what should my thetas be? Yeah. Do you want to do pi fourths? Yeah. I think we need it. I think we want as many points as possible. pi fourths, it's gonna help us on our image.
When it's only one quadrant?
I mean, yeah. More points, the better. Pi halves, and then I'm gonna leave it there. Okay, 3 cosine of 2 times 0. So that's just 3 cosine of 0. What is cosine at 0 radians? 1. And what is 1 times 3? 3. So I'm at 3. Okay, next one. 3 cosine of 2 times pi 6. Okay, pi thirds. What's cosine at pi thirds? 1/2. 1/2 times 3? 3 halves. Okay, next one. 3 cosine 2 times pi fourths. My middle simplifies to 3 cosine pi halves. So up top, right at 90 degrees. Yeah, it's 0. So cosine at pi halves is 0. 0 times 3 is 0. Okay, try the next 2 points on your own. Okay, last one. 3 cosine of 2 times pi halves. Simplifies to pi inside. So what is cosine at pi, Davian? -1. And what's -1 times 3? -3.
Cosine 0. Right?
So cosine is our x values. So I'm at pi.
Oh, wait.
Because it's 2 times pi halves. So at pi.
Oh, I don't know why. I was looking at this one.
Oh, okay, that would be 3 pi halves. Any question about how we got our points? No. Okay. Let's plot them and then reflect them. So we need 3 circles.
Let me draw them right here.
Oh yeah, that's what I'm about to do too. I think it's much easier. Let me find a blank pen. I can almost do it. Perfect. Okay. We got 3, 0. So I have radius of 1, 2, 3, and I go up 0. So we're just right there. Okay. Next one. 3 halves. So about right there. And up pi 6. You guys want to try graphing on your own? Okay. Do it on your own. Graph your points. I would connect the lines and we can talk about something exciting. You guys all got it. Next one was 0 pi fourths. And then okay, we should have a curve something like this. What do you want to reflect over first? Anybody can pick. What do you want to reflect over first? Pi halves. So we're flipping this way. So if I flip this way, this point ends up on the opposite sides of 1, 2, 3. Ends up there and there. That point's still there. Now we're kind of flipping it the other way. So this one ends up right there and right here. And then let's connect them. Yes, polar axis. So I'm going to flip it this way. I'm going to flip it up. So if I'm 3 down, I'm going to go 1, 2, 3 up. That should be right about there and there. So that should be my top half. Dolan, where should this point go if I'm flipping over the polar axis? So I'm kind of flipping it from this way over this way. Yep, down, straight down until we get to the pi 6, so at 11 pi 6, so right there. Perfect. And let's do the same thing to the other side. Oh, I think I messed up that point right there. So it should be more like right there. And right there. Perfect. Okay, did we get an image like this? Yeah, that's really fine.
It's disgusting. I'm almost done. I'm just color coding it so I don't get confused. Okay. Wait.
Okay, if you're done, you can check the symmetry on the next one.
We checked for this one and this one, and that means we also have the whole one. Yeah, we have 3.
So, Dolan, on this one, how many petals did we say we were going to have? Do we have 4? Great. Good check to see if we got that right. So because it's r square root, so before with the rose curve, they only apply to equations when r is not a square root. So this one, we are going to have something different.
How do we check the petals on this one?
I don't think you can check the petals on this one, but we're gonna have two.
We are going to?
We're gonna have
Oh, we're gonna have
two petals, that's it. Yep. Yes, all three. Check all three. So these are the ones you truly do have to check for symmetry. Yeah. So I've checked three things.
Three?
You gotta check one, two, like if it's over the pole axis, if it's over pi halves and the pole. Yeah.
So we only don't have to do the pole one when it's.
When you check the other two and they're good. Yeah.
But also yesterday, when it was.
So when we do it, when it's just like,
There's no number from the thing that we don't have to do pole.
yeah,
Okay.
you just have to know even odd which ones. Sine is always gonna be over.
Wait, can it be the pole one? No.
No.
Not when there's.
No, it's always gonna be over pi halves, and then cosine is over pole axis. Yeah. Did we check the first one? Okay, so r squared equals 4 sine of negative, wait, we would do 2 negative theta. We'll say that. So the 2's in our function.
Oh.
Yeah.
I had the two. I don't know why I asked that.
And then because it is, we're gonna scroll up again for a second.
Why is it not negative 2 theta? It's.
You can. I was just trying to make it simpler. We're just plugging in 4 theta. So we, same thing, sine negative 2 of theta. So that 2, because it's an odd function, comes out front. That negative comes out front. We have 2 of theta. Because it's an odd function, so it just.
Function.
So it's the same thing. If I go up 5/4, like here and here, we have the same. Well, like I have the same values here, but if I reflect this on
Casey, is this the same as our original function? No. So no symmetry right now. Perfect. Okay.
well, there's symmetry, odd means symmetry, but even means symmetry by the line exists. So like a parabola.
So because it's sine, you can pull the negative out from the argument and put it in front.
Mm-hmm.
You guys are gonna get so good at double angles.
Check the next two.
Yeah, that's 2 pi minus something rather than
Yeah.
double angling everything. Or some different.
We did the double angling.
We did, yeah, some difference yesterday, I saw, right? But we have to, we don't have. Like, it's like,
Is this function the same function as that? No, so then no symmetry.
no, but like,
Yeah.
it's the same factor. Like,
So let's play the next one, right?
That's a weird way, like, that's why I can't say, like, if there's, does that make sense? You would say.
Whenever you see a theta on a function, the way there's our function I minus theta. Yeah.
For the last, we just make our squared equation.
Okay.
For the third.
Is it inside the fun? So you made the 4 right? We make the odd negative.
So there's no symmetry. So sine can't really be negative in the argument to the front.
Right, but you can just, so goes at 30 degrees, goes at negative 30 degrees, here's the exact same.
Do I have symmetry over r equals pi halves? No. So no symmetry. Okay, should we check the last one together? Yeah, okay. R is becoming negative. So now we have negative r squared equals 4 sine of 2 theta. If I take two negative numbers and I square them, what happens every time? Yeah, they just become positive. So this is still a positive r squared equals 4 sine of 2 theta. And then is this function the same as our original top function? Yes. So we have symmetry over the pole. Pole is the same thing as the origin. So what quadrant do I have to make a table with? Yep, just quadrant 1, because we're just talking about reflection over the pole.
Why did we put negative in front of the r? I thought we put
Because
the negative in front of the 4. I know I'm wrong.
Because we're doing r of theta equals negative r of theta. So r is out front in front of.
There's no theta by the r. 4 means 8. 4 means 8.
So instead of our function, we're putting it outside of our entire function. So out front here. Out front of the r.
How come the one left has a theta after the r, but there's no theta after the r in ours?
Say it again.
Like it says r theta equals negative r theta, but there's no theta next to r when it's r squared.
So remember like f of x? Like we have f of x. It's the same as like y. Kind of thing. So we can say this whole function is like r of theta squared equals 4 sine of r of 2 theta. You want to say it like that? And you're just saying that our argument, like our x value, is going to be theta.
Oh, yeah.
Yeah. It's kind of like f of x. So it's kind of like r of theta. Yeah. So it's just acting upon r of theta. Yeah. Cool. And here it's like, okay, now we're changing our theta, our arguments, to like pi minus theta. Okay. We're doing r, we're doing theta for sine of 2 theta, and we're checking quadrant 1. So we got 5 points to check. So for sine at 2 times 0, which is just 0. So what is sine at 0 radians? Yeah, it's 0. So we just have 0 over here. Okay, next one. 4 sine of 2 times pi 6. So that reduces down to pi thirds. So what is sine at pi thirds? 4 times root 3 over 2. Which is same as 2 root 3. 2 root 3, we're going to have to do that as a decimal in a minute. But we can keep going. 4 times sine of 2 times pi fourths. So that would be pi half. So 4 sine at pi halves. Pi halves for 1. So this is 4. Okay, next one. 4 sine of 2 times pi thirds. Yep, root 3 over 2, which would equal 2 root 3. Okay, next one, last one. 4 sine of 2 times pi halves, which would be 4 times sine of pi. What is sine at pi? 0. Okay. We're not done yet. Not yet. Yep, gotta square them. So it's not just r, we have r squared. So we have to square each one. So take a square root of each one. Yeah, square root. Square root. I need square root of each one. So right now we have r squared equals
So isn't r squared the ones we found? And then
we
r the
found
ones we find?
r. Yes.
The ones we already found is r squared, I'm pretty sure.
No, I think you're right, because we have them all squared. Yeah. No, okay. We have r squared. We need r. Because on our polar coordinates, we are doing it by r. Yeah. So we need r. Now we're taking the square root of each one. So square root of 0 is 0. Square root of 2 add 3 is, I don't know, off the top of my head. So plus or minus 1.9. That is so true. It is time to go.
No bell today.
I know. I forgot to give someone. You guys want homework?
Oh, I took all the time made for you. I'm not offended by the day today.
Homework. 10.8. This is the end of polar. We're done after this. Yeah. 14, 17. I picked a lot. Ooh. 27, 36, 39, 47. Okay, let's not do the last one. 71. 1, 2, 3, 4, 5, 6, 7. I don't know, and I'm sorry. Yeah.
We had a 10.8.
Yeah, I feel like it's page 753. I don't know why. I feel like it.
Bye.
Bye.